Okay, so this should be part 3 of the video, and right there is the theorem that we just went over. So it shows that angle 1 is the average of arcs AB and DC, and angle 2 is the average of the other arcs AD and BC, but the ones not highlighted in red and blue. Okay, if angles intersect outside the circle, you subtract the arcs and divide by 2, which I wanted to show you on GeoGebra first, but whatever. You get the theorem ahead of time. Alright, so let's just look at that real quick on GeoGebra. Alright, so let's say I have a circle and I have secants, so those are lines that intersect outside the circle. Okay, so something like this. Okay, then we have this point right here. Now, I'm going to find these angle measures, CAE, because CAE represents this arc right here. I'll make the font a little bigger so you can see it. Sorry, I probably should have paused the video, but at this point there's no turning back. Okay, so this arc CE is 18.5, and then if I find this angle, BAD, this arc is 71.6. Alright, so I'm going to adjust these to make these rounder numbers. So let's make this like, alright, let's make this 78.4. So this angle F, I'm going to predict that it's going to be, let's see, do some math in my head. It's going to be 30 degrees. Wow, I'm a genius. Pat myself on the back. How did I do that? Well, it's because it's this arc, so 78.4 degrees, minus this arc, 18.5 degrees. That difference is 60, and then divided by 2. So when they intersect outside the circle, instead of adding the arcs together and dividing by 2, we're going to subtract the arcs and divide by 2. Okay, so this slide is a summary of all the angle-arc relationships that we know. So in the upper left we have central angles. Okay, those are equal to the arc measures. Inscribed angles are half. If the chords intersect inside the circle, it's going to be the average of the arcs. If they intersect outside the circle, it's going to be half the difference of the arcs. Okay, here's like a kind of a special case here where if you had two tangent lines intersecting at a right angle, notice how it creates two arcs here from B prime to B, where that's 90 degrees, and then from so that means the remaining part, the exemplary angle, I think I messed up that pronunciation, but the part that adds up to 360, that part's going to be 270. Subtract these two, you get 180, divide by 2, and that's where the 90 comes from. Okay, so in summary, if lines intersect inside a circle, add the arcs that they intercept and divide by 2. If lines intersect outside the circle, subtract the intercepted arcs and divide by 2. Okay, so we're going to do one more video after this, and it's just going over a couple examples.